For question 3, it says, compute the volume of the solid formed by the region bounded by the graphs y equals sine x, y equals cosine x, and with bounds from 0 to pi over 4, rotated about y equals -2 using the shell, disk, or washer method. First, we can start by drawing the graph. And drawing our function. We can first draw y equals sine x and y equals cosine x. They intersect at pi over 4. And we're rotating around y equals -2. So then we're going to have this shape. For this figure, we can use the washer method. We have an inner radius and an outer radius. And the formula that is used for the washer method is v equals pi from integral a to b of the outer radius squared minus the inner radius squared, dx. Here we can identify that the inner radius is going to be 2 plus sine x, and the outer radius is going to be 2 plus cosine x. We know this because we have the function from here to here, which is sine for the inner radius, plus the distance from the x-axis to the axis of rotation, which gives us the 2 plus sine x, and same for the outer radius, 2 plus cosine x. Now we can plug in our outer radius and inner radius, and we will get v equals pi integral from 0 to pi over 4, which are our bounds, 2 plus cosine x squared minus 2 minus sine x squared. From here, we can FOIL the 2 plus cosine x squared and FOIL the 2 minus sine x squared. Then we would get v is equal to pi with integral from 0 to pi over 4 plus 4 cosine x plus cosine squared x minus 4 plus 4 sine x plus sine squared x. And we still have our dx for each of these. Now we can distribute the negative here, and we will get v is equal to pi integral from 0 to pi over 4 plus 4 cosine x plus cosine squared x minus 4 sine x minus sine squared x dx. From here, we can cancel these 4's, and we can use the half angle formula to substitute the cosine squared x and the sine squared x. Then we would get v is equal to pi integral from 0 to pi over 4 cosine x plus 1 plus cosine 2x over 2 minus 4 sine x minus 1 minus cosine 2x over 2 dx. We can split the 1 plus cosine 2x over 2 into 1/2 plus 1/2 cosine 2x, and we can do the same with 1 minus cosine 2x over 2. This will give us v is equal to pi integral of 0 to pi over 4 cosine x minus 4 sine x plus 1/2 plus 1/2 cosine 2x minus 1/2 plus 1/2 cosine 2x dx. Then we can cancel the 1/2s. And we end up getting v is equal to pi integral from 0 to pi over 4 cosine x minus 4 sine x plus cosine 2x, which we get from combining the 1/2 cosine 2x and the 1/2 cosine 2x dx. From here we can integrate normally, and we will have v is equal to pi parentheses 4 sine x plus 4 cosine x plus 1/2 sine 2x with bounds from 0 to pi over 4. Plugging this in, we will get v is equal to pi parentheses 4 sine pi over 4 plus 4 cosine pi over 4 plus 1/2 sine pi over 2 minus 4 sine of 0 plus 4 cosine of 0 plus 1/2 sine of 0. Getting the value of these, we get v is equal to pi parentheses 2 square root of 2 plus 2 square root of 2 plus 1/2 minus 0 plus 4 plus 0. Adding these together, we get v is equal to pi 8 square root of 2 plus 1 over 2 minus 4, which gives us pi times 4 square root of 2 minus 7/2. And that is our final answer.